So, in this lesson, we're going to be talking about similarity criteria. Now, we talked about obviously proving two congruent triangles proofs. We know when we try to prove two triangles congruent, we have five theorems that we use. Well, we're going to start talking about similarity proofs. Not quite in this lesson. We're gonna talk about it a little bit, but in the next few lessons, we're really going to get into proving two triangles similar. This lesson, we're going to talk about the theorems, if you will, on how we prove that two triangles are similar. Now, we talk about it throughout the lesson, but I want to talk about it right now. So the first one is what we call angle-angle similarity. The next one is side angle side similarity. And the third one is side 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 similarity. Now, I'm not going to go into depth right now, but these are the three theorems, quote unquote, that we use to prove two triangle similarity. Now, you're probably thinking side angle side, side side side. That's two of our theorems that we use to prove two triangles congruent. Yes, it is. These two, the similarity side angle side and the side side side, are not quite the same as side angle side congruence and side 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 congruence, but we're going to talk about them. They're similar, but they're a little different. We're going to talk about them. All right. Now, in exercise 1, they have directions for us. I am not going to go completely through this whole exercise. I'm going to kind of ignore these directions. I just want to talk about the first criteria called angle-angle. Now, this is arguably the most important, maybe not the most important, but the most most common theorem that you guys will be seeing when talking about, especially when proving two triangles are similar, when we get into similar proofs. This is also the most basic, okay? Now, angle-angle criteria, as we can see right here, is if two angles of one triangle are congruent to two angles of another triangle, the two triangles are similar. So let's take a look at this one. Let's go back up here. So we are given triangle ABC and we are given triangle DEF. Angle A is congruent to angle D and angle B is congruent to angle E. Now, since we know that angle A is congruent to angle D, angle B is congruent to angle E, we can use our angle-angle to say that these two triangles are similar. So triangle ABC is similar to triangle DEF by angle-angle similarity. Okay. Now that's it, right? That's all we need. We only need two for this theorem, for this criteria. We only need to know two angles are congruent to say those two triangles are similar. Okay. All right, so let's look at exercise 2. So in the diagram below, QR is parallel to NP. We want to prove that triangle MQR is similar to triangle MNP. So this is kind of our first similarity proof. Now we set it up just like we do our congruent proofs with our statements and reasons. Okay, so this is what we are given. So QR is parallel to NP. Now we want to prove that triangle MQR is similar to triangle MNP. Now we're going to use our angle-angle. So essentially, all we have to do is to find two angles that are congruent in these two triangles to prove that this triangle is this triangle is similar to this triangle by our angle. Okay. Now I'm looking at this and I am saying to myself, well, M is part of both triangles. So M is congruent to itself. So I'm first going to say angle M is congruent to angle M by our reflexive property. Now our third one. Now we were given that these two lines are parallel for a reason. Now we don't have any alternate interior angles, but we do, however, have corresponding angles. Now this one is congruent to this one, and this one is congruent to this one. Now we don't need both of them since we already said angle M is congruent to angle M. We just need one. So I'm going to say that angle MQR is congruent to angle MNP. Is because if two lines are parallel, then these are corresponding angles are congruent. Okay? Now, since we have a congruent angle, we have another congruent angle. We can say triangle MQR is similar. We're not saying that they're congruent. We're saying they are similar to triangle MNP by angle similarity. Okay. And for that, we are done our proof. We prove that these two triangles are similar. All right, so let's take a look at exercise 3. So if in the above diagram, MQ is 8, NQ is 6, and NP is 21, then what is the length of QR? I am going to draw this out. Now, we're going to have to solve another proportion. Now, if this helps you, I highly recommend you do this, whether you feel you need to or not. Separate the triangles, separate your diagram. It's much easier to see. It's much easier to understand. Okay, so let's go back to our little diagram there. So MQ is 8, NQ is 6, and NP is 21. You want to solve for QR. So I'm going to go back to my diagram here. So MQ is 8. Okay. NP is 21. We want to find QR. Now here's the thing. MN is the length of MQ plus the length of QN. So 8 plus 6 is 14. Now, this is one of the reasons why I feel like in this case, with this specific diagram, it helps to separate the triangles like this. Okay? So now we're going to solve our proportions. So we need to solve for x. So let's do x over 21 is equal to 8 over 14. Okay? So we're going to cross multiply. So we get 14 times x is equal to 8 times 21. 8 times 21 is equal to 168. I'm going to divide that by 14. So x is equal to 12. So the length of QR is equal to 12. And if you guys need the work, I'll put this back up real quick. All right. So now let's look on the next page. All right, so now we're going to talk about side, and we're going to talk about side angle side similarity. So let's first talk about side similarity. Now, while I'm writing this, let's talk about side congruence. So we know using side congruence that all three sides of a triangle, all three sides of both congruent triangles are equal. Now, we know that similar triangles are a little different than congruent triangles. We know in similar triangles that the sides are proportional, so their ratios are equal. So in side, side, side similarity, instead of the three sides being congruent, the three sides are going to be proportional. Okay, so let's say AB is 6, this is 8, this is 10, this is 12, 16, and 20. Now, because all of the ratios are equal, so let's show that. So 12 over 6 is equal to 2. 20 over 10 is equal to 2. 16 over 8 is equal to 2. So as you can see, the corresponding sides, their ratios are proportional, or the corresponding sides are proportional, or their ratios are equal. Now, since corresponding sides are proportional, just like I said, by side, side, side similarity, triangle ABC is similar to triangle DEF. So corresponding sides have to be proportional for two triangles to be similar by side, side, side similarity. Okay. Now let's talk about side angle side similarity. So side angle side similarity is where two sides of a triangle, so the two sides are proportional, but their included angle is congruent. So let's say I have AB is 3, 6, 4, 8, and I don't know, let's do 70. Right? Now, since angle B and angle E are congruent, so angle B is congruent to angle E, that is the included angle between these two sides. Now, 6 over 3 is 2, and 8 over 4 is 2. Okay? So since two pairs of sides are proportional and the included angle pair is congruent, then by side angle side similarity, triangle ABC is similar to triangle DEF. All right. So that's what side angle side and side 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 similarity are. Like I said, they're kind of similar, no pun intended, to what we know for our congruent side 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 and side angle side theorems, but instead of them the sides being congruent, the sides are proportional. Okay. So let's take a look at the next page and let's take a look at exercise 4. Okay, so say we have the following diagrams with only the information marked. In both cases, give a dilation with a center and factor that would map triangle ABC onto A prime, B prime, C prime that is congruent to triangle DEF. Now justify the congruence using a congruence theorem. All right. We're not going to do that. But however, we're going to talk about why these two triangles are similar. Now, as you can see, ABC we have 3, 4, 5, and DEF we have 6, 8, and 10. Now, as you're probably able to tell, we are given the three sides of the triangle. So, in order for two triangles to be similar by side, then all three sides have to be proportional. All three sides have to have equal ratios. And why? Because 10 over 5 is equal to 2, 8 over 4 is equal to 2, 6 over 3 is equal to 2. So since corresponding sides are proportional by side, similarity, triangle ABC is similar to triangle DEF. Okay. So I'm going to do the same thing with B. Are these two triangles similar? Why or why not? And what theorem proves that these two triangles are similar? Right, so let's go over it. So these two triangles, are they similar? So, well, 15 over 10 is 5 over 2. No. 3 over 2. 21 over 14 is also 3 over 2. So those two sides are proportional, and since the included corresponding angle pair are congruent, these two triangles are similar by side angle side. Okay, so since angle B is congruent to angle E, and the two pairs of sides are proportional by side angle side similarity, triangle ABC is similar to triangle DEF. Okay. All right, let's take a look at exercise 5. So in the diagram below, which of the following information would not be sufficient? So which one is false to show that ABC is similar to RST? Now here's a case where the diagram A is slightly confusing, and B, it'd be helpful for you guys to number your letters so you know which sides or which angles correspond to which whatever. All right. So let's take a look at one. So RS over AB is equal to ST over BC is equal to TR over CA. Well, let's kind of look at that more closely. So RS over AB is equal to ST over BC is equal to TR over CA. So do these match up? So RS is 1, 2. AB is 1, 2. ST is 2, 3. And BC is 2, 3. TR is 1, 3. CA is 1, 3. Now, since all three sides are proportional, now this one's by side similarity. That one is true, so that one is not our answer. All right, so let's look at number 2. So AB over RS is equal to AC over RT, and the measure of angle A is congruent to the measure or equal to the measure of angle R. So let's, again, draw it out, talk about it. Okay, so RST T, and we have A, B, C. Okay, so our second choice is AB over RS is equal to AC over RT. And the measure of angle A is equal to the measure of angle R. Now, angle A and R are corresponding angles, yes. But, however, in order for this to be side angle side similarity, angle A and angle R need to be the included angle. Okay? So now AB is similar AB over RS. Okay, so that's corresponding side over corresponding side. And AC over RT. So those match up. Now, as you guys can see, so we have this side and this side. So as you guys can see, A and R are that included angle in between those two proportional sides. So since that works, our answer cannot be number 2 because, again, we're looking for the false one. Okay? So now let's look at 3. So the measure of angle S is equal to the measure of angle B, and the measure of angle C is equal to the measure of angle T. So C and T are equal, B and S are equal. Now this proves angle similarity. We just said this was side angle side. Since we have two corresponding congruent or two angles that have the same measure, so that works. So the only one that could be false would be number 4, but let's talk about why. So let's draw our diagram. Okay, so we have RT over AC. Okay, so we have B is congruent to S. So that is true, yes. So we have RT over AC. And we have TS over CB. Now, yes, those are proportional and this proportion is set up right. But do you see how angle B and angle S are not the included angle? So since they are not the included angle, this cannot be side angle side similarity. So that's why choice 4 is our answer, because this does not work with what we have.